Often, when we look at a mind blowing 3D art or a special effect inside a game or a movie or even in an application, we wonder how this thing came out so nicely. It can be an environment art or a stunning character with some really good surface scattering on it, or even it can be as simple as a holographic effect which we see in some of the great movies or inside gaming environments. And that's where the shader comes into light. They are being used for creating various different effects. So coming back to the main topic of this tutorial, which is amplify shaders. Amplify shaders are just like any other shader, but the thing which make them stand out is its visual scripting workaround. Unity has also released its own visual scripting shader editor back in 2018, but it still needs some sort of critical updates, as I still believe. So without wasting any further time, let's just dive into Unity. So this is a simple sphere which I imported from 3ds Max. I have unwrapped it in 3ds Max. Although you can also use the same sphere from inside Unity, inside game objects, 3D objects, and we have different objects which we can use. But I would recommend that if you use the objects from a 3D package, that would be much better because you can unwrap it according to the need of the project or according to your requirement. And I'm using the simple 3D pipeline for this project. So it's pretty basic. I'm not using those different sort of pipelines which Unity offers. And uh, before we start working on the shaders, basically shaders are all about mask. So we need to create different sort of mask to achieve the end output. And once we have created all the masks, we just multiply it, or sometimes we add it to get the end output. So this is the shader which we'll be creating. It's pretty basic. It's a holographic shader which I created, and I got the inspiration from Watch Dogs while I was playing it. And before rebuilding the shaders, I have, for better understanding, I have divided this particular shader in different six masks. So basically, there are six different masks which are working in this shader. And the first mask is this particular lines, the horizontal lines which we are seeing. There is a mask for this, so this will be, these lines will be our first mask. And you can see that there are some noise over those lines, so that I have created a noise mask for that. So second will be the noise, and then there is some cloudy effect on overall globe. So for that cloudy effect, there is another mask. So that would be our third. And then you can see clearly that there is some hexagons which we can see, and they are also animated. So hexagons are our fourth mask. And there is also a Fresnel effect over the whole globe. So that Fresnel effect is basically our fifth mask. And then as you can see that this whole sphere is not fully visible because there is a particular mask which I have used to make it a semi-sphere. So that particular thing will be a sixth mask. So let's just build these masks step by step. Well, so this is the uh, it's not pretty complicated actually. So this is the shader graph which is creating that particular effect over there. Over here we have the master node. Once we have created all the masks, we will multiply those masks. We will add those masks according to the project, and then we will add it to a master node. If we don't add the nodes to the master node, then the mask will not work actually. So let's just begin. Although I have created all the mask over here, line mask, the noise mask, and the hexagon mask, but let's just create the line mask again from scratch. So I have created a 2D texture for the line mask in Unity, in Photoshop, which I will be using for that particular line effect. But in order to work inside Unity, I will create a texture node. Here we have different RGBA properties, and then we will use a saturate node in case to avoid any color bleeding. And then we're gonna use a lerp node if we need much more control over the mask. Then I will just quickly show you then what is the use of lerp node over here. And we need a one minus node, and here, and let's just connect this to the lerp A and one minus to the B. So if you know how a lerp works, lerp is basically a blending node, I could say. So we can blend two particular colors or two particular textures on a model using a lerp node. So suppose there is a color red on node A and there is a color yellow on node B. So we can blend those two colors using the lerp node, and the alpha property is the one which will blend it. So we will add a float so that we can control it from the material editor. We don't need to come inside shader every time. So I will add this, and yeah, that's it. Basically our a very simple line shader is created, and we can invert the particular line mask using a lerp, and we can control that using a float node. And now if I let's connect this to a master node, and if I add this to a debug node, so a debug node is a very cool feature which we have in Amplify shaders. I am not sure whether we have this in Unity shaders, but yeah, I don't know. But this is a very cool feature which we have. So what debug nodes does is, as you can see, we have already other nodes connected to our master node, but whenever we connect anything to the debug node, all other nodes are basically deactivated. Only the debug node will work. So it helps a lot when we are working with lots of different masks inside a shader. Right now we just have 6 different masks, so it's pretty easy to understand, but sometimes we have more than 15 or 20 masks just in one shader. And just to check out what a particular mask is doing in that shader, we use the debug node. So it's pretty important node. So let's just check out the our new line mask which we have just created. I will just compile it. So this is the compile button. Whenever we create or add a new node or we made any changes, we need to compile our shaders again. Otherwise, we will not see the result over here under the material node, material properties. So I will just compile it and just close it and select our globe. And yes, so see, we added a texture sample 0. So when I click over here, I get a property of texture sample 0 where I can add my texture, which I created in Photoshop. Although we can rename it here like line mask tutorial. And again, we have made some changes, so I need to compile. And yes, it's renamed. And we can add the texture over here, which I created in Photoshop. And that's it. Yeah, see, our texture is over here. We can obviously change the tiling of it, 6 6. And yeah, but the thing is, we don't see any property to change, to invert this particular mask, but we created inside shader, but we can't see over here. So the reason behind is, whenever we create a float or a vector one or a texture map, we have to change its type from constant to property. So once we have changed the type to property, we need to compile it again, and that's it. Now we can see our float 3 over here. So right now it was 0, and if I change it to 1, see, the mask is inverting. So basically we are blending it. So that's how the lerp node works, and it's pretty helpful when we need to animate a mask or we need to invert a mask. It's very helpful. And we can also create a slider for it. So if we click on our node, then the minimum value is 0, the maximum we can give 1, and automatically we will get a slider over here, and then we need to compile it again. And yeah, see, on 0 it's working like the actual mask, and on 1 it's inverting the mask. Yeah, so our mask is working, so our line mask is created. It was pretty simple. We can disconnect it. Yeah, and once we have created our mask, once a mask is created, and now all we have to do is we have to multiply this mask with a color node or whatever is whatever you're trying to do. But for now, just for the explanation, let's create a color node. Sorry. And again, we need to change it to property, and we will multiply this. We will multiply our mask with the color. And again, we will add this node to the debug, and let's just compile it and see. Yeah. So now we have a color node, we have our mask inverter. So we can invert our mask, and we can change our mask. We can use any different other mask if we have, it will work in the same way. So it's pretty cool, right? And again, we have a color node, so we can change the color. That's it. So our first mask is created. So this is our line mask. And now let's talk about the noise mask. Noise mask is basically, I have used a noise generator for creating a noise mask. So in Amplify Shaders, we have this noise generator, and all I have done is I have changed the scaling value of this noise generator to 50, and I have changed the type of this to simply simplex 2D. Although you can change it to other, and you can see the different effects, and you can use it whatever suits you according to the project. So it's pretty nice. So it's just this, and then I have used a texture coordinate uh, for the noise generator. So if you know how a texture coordinate works, it's like very simple. A texture coordinates basically tells about the UV properties of our mesh, and we can manipulate the UV properties using our texture coordinate. We can increase the tiling, we can change the offset of our UV map of a particular object, and yeah, that's it. So I have created a texture coordinate because I wanted this noise to be animated, and for the animation thing I have created a time node. See, if I remove this time node from the offset, you can see the noise animation is automatically stopped because the time node is the one which is actually animating the noise. And there is a negate option which is quite similar to 1 minus, but it's not like 1 minus. Their mathematical background, mathematical calculations are different. But for now, you can just understand that it is reversing the way how the normal time node is working. In this particular texture node, the direct time node is attached, and you can see the animation is going from downwards to upwards. And when we use a negate node, and then the animation is coming from upwards to downwards. We have created these two particular noises, we have multiplied it, and we have saturated so that we can avoid any color bleeding or any exposures. And once is that, now we have, so now basically we have created our noise. This is our noise mask, and here we created our line mask, if you remember. And there is a pretty cool thing inside Amplify Shaders. Once we have created our whole mask, we can register it. We can, yeah, we can just register this particular mask, and we can rename it like line mask tutorial. And once it is registered, we can call this mask with just one node in anywhere or in anywhere in this graph. We just have to, suppose if we need the line mask over here, what I will do, I will just write get, and under the selection I will get an option of line mask tutorial which we created just now. And I will simply, so basically now I have called this whole mask over here with just one node. So it's pretty helpful. It makes the node graph less messy. And now we have multiplied our line mask and our noise mask. We will multiply it, and we will add it to our master node. Let's see what happens. This is a master node, and compile it. And yeah, see, it's working perfectly. So we have a line mask, and over the line mask we can see the noise. It's just the way we wanted it. And obviously we created over here, if you remember, we created using the lerp node, we can invert our mask. So if we invert our mask now, yeah, it's working perfectly fine. And again, if you want to give any color over there, you can again just multiply this with the color node, and we can see the color effect over there. Again, let's create a color, change it to property. We need a multiply node. So let's just add our mask, and we're gonna multiply our mask with a color, and let's just add it to the albedo and compile it again. And yeah, see, it's working. Cool. So that was our noise and line mask. Now we will just quickly talk about our hexagon and cloud mask, which they both are pretty similar. I will quickly explain those masks. So we have again used hexagon texture. I can show you. There is a texture which I have used here. I just downloaded this texture from Google. And wait, just a minute. Where is it? Under textures, we can find it. Yeah. So this is the hexagon mask which I downloaded from Google, and we are using this. And this was the line mask which I created in Photoshop. It's very simple actually. Again, let's go to the shaders. So yeah, here is our texture map which we have created. Again, we have used a lerp node, and there is one minus, so that, and again using a converter. We are using the alpha property, and we are using a float one to convert the hexagon mask the way we did for the line mask. And once the mask is created, I have multiplied the mask with a color, and I have given a intensity property so that I can increase the intensity, increase the brightness of the color. And again, I have registered it as a hex node. So as you can see, our hexagon and the clouds, they are animating, they are not still. So what node is making them animated is panner. I have used panner. So basically I am animating the UVs of that particular texture using a panner node. And in panner node we have this UV section basically, and we have a speed. So I have created a vector 2, and its name is hex speed. So see, we can see it over here. Yeah, so hex speed. So if I increase this, see, the animation speed will increase the X. And if I increase, now if I put it to 0, it will stop. If I increase the value of Y, so it will start animating in the Y direction. Yeah, so that's how it works. So for the animation, I have used a panel node over here. So that was our hex node. So we, again, if I quickly recap it, there is a texture node. We have used a lerp node, one minus node, and then we are using a invert hex. We are using a float one, and then we have multiplied with a color, and now then we have multiplied a float one with it so that we can control the intensity of that color. And here we are animating the UVs of this texture using a panel node. It was quick. And the cloud node, this is the cloud node, and it is made in the very same way. We have created a hex node. Only the thing is, we have changed the uh, cloud texture, and I can show you. So these are different cloud textures which I created. So yeah, so this is the cloud texture. You can download it from Google, and you can just manipulate the texture in Photoshop and import it here. But once you import it, you need to change its property and mark is alpha is transparent. So this is our cloud mask, which is, as I said, which is very similar. We have again, for animating the clouds, we have again used a panel node, and we are controlling the speed of the cloud animation using our vector 2. And in the same way, we have used this texture coordinates. And then comes our Fresnel mask and the semicircle mask. For the Fresnel mask, it's quite easy. I just use a Fresnel node which is in built-in Amplify, and I created a Fresnel intensity node so that I can control the intensity of a Fresnel mask by just multiplying it, and then I again created another intensity controller by just doing a 1 minus so that I can invert the Fresnel mask. And here we have different properties under Fresnel, and I created different nodes just to control these properties outside shader graph. We can see all these here, the power, scale and bias. We can also add a normal map if you want for a little bit of more detail over the object. And then I just added the two multiplications, and I clamped them in between a value of 0 and 1, and that's it. That's the Fresnel mask is. And like other mask, I multiplied my Fresnel mask with a color node. So that was the Fresnel. And semicircle, the semisphere mask is quite simple. I just simply use my vector position, and I can show you how is it working if I add a vector position over here and I connect it. You can see. So this is the vector position. You can try out different channels. So basically the vector position works according to the object space. It's not working according to the world space. And this is the reason I wanted vertex space, because even if I move my object anywhere in the space, anywhere in the environment, the mask will stick according to the object space. But I can quickly show you what happens when if I have used a world position. Let's add it to debug. See, the mask is similar to the vertex position, but when I move my object, the mask is not following around the object. It's working according to the world position, and it's not good when you are animating the object, because your object will be constantly shifting positions. So that's it, and I added my vertex position to a smooth set so that I can get little bit of more control over the fade in and fade out, because if I connect this mask and I wanted to control little bit more over here so that I can control the fade in and fade out effects of it. Previously it was quite sharp and I didn't want that, so I added this. So it's pretty simple. So that this was a mask, different mask, and in the end, when all our masks are done, I have simply added the hexagon, the final output of hexagon, Fresnel, cloud, and the line. I added them, and I added them to the emission node, because this is a transparent shader. It's a holographic shader. That's we don't want to use the albedo. We want it to be in the emission channel. And then we have another nodes which are connecting to the opacity channel. So this is something really important when you are working on a transparent shader or a holographic effect. You are creating a holographic effect, then the opacity channel means a lot, because it defines that this object is transparent and it should work as a transparent object. I can quickly show you what happens if we don't properly connect our nodes to the opacity channel. So right now, if, sorry, if I remove the opacity channel and compile it, you can see the effect which we created, which we have connected to the emission node over here, but it's not transparent anymore. So that's why the opacity channel is pretty important. And here I have added the cloud mask, I have added my line mask and the hexagon mask, and then I have multiplied that with a semicircle mask which we created over here. And then for controlling the opacity right from the material editor, I have created a opacity node, and I have multiplied all these three and added to the opacity. And I can quickly show you how the opacity is working. So this is our opacity node. We can control the fade in and fade out of this opacity node. You can animate it sometimes. So that's it. That was our final shader, and let's just check it out one last time in the game mode. Okay, we can slightly, yeah. So that's how our shader looks like after it's done. I hope you liked it. I hope you understand something about Amplify shaders and how the nodes will work. Here we can see that we are seeing this little bit of fluctuating effect. So for that I just simply animated my cloud alpha position. You can see it's being animated as we are in the play mode. So that's it. And once we have done this, what we can do is once we can simply add this object. We can create a prefab of this object. So for creating a prefab, you just need to drag and drop, and that's it. Now we have a prefab, and you can use it anywhere. You can use it multiple times. You can even use this prefab in other project. So that was it, and I created a simple node basically to make it work. Like, let me just quickly show you. So I created this node for creating the fade in fade out effect. You can add a button, and when you press the button you can add these animations. I mean, you can just play around with your creativity. So yeah, that's it. And I also created a pretty short document. um, I will attach this document as well, here, so you can just refer to this document, and you can check what different masks we're doing. You can just understand it again. I will attach this document with this video. So that's how the different masks were working. You can just check it out. Yeah, so I hope you like this and you learn something new, and thank you for watching this video.